Assalamualaikum everyone. Hi, welcome back. So from now onwards, I'm going to be making this kind of videos, okay? Because I think I'd be able to explain better if I can scribble and, point to the questions directly instead of preparing PowerPoints. I hope you don't mind and will be able to follow the lectures with me. So today we're going to learn on how to find the value of random variables when probabilities are given. Okay, so in other words, unlike before where we are asked to find probabilities, this time around we are given the probabilities, but we're going to be finding the values of x instead. Okay, so if you can turn to page 46 of your lecture notes, you can read this part. Okay, another application of the normal distribution is to find the value of an observation or x or random variable when the probabilities are given. Let us look at example 16. For the most recent year available, the mean annual cost to attend a private university in the United States was $26,889. Assume the distribution of annual costs follows a normal distribution and the standard deviation is $4,500. 95% of all students at private universities pay less than what amount? Now, if you noticed in this question, they're not asking you to find probabilities. Instead, they're asking you how much do 95% of the students pay? Okay, so here I've already defined the x or random variable for you, but be sure to do that on your own, okay? So in this question, x is the amount of cost to attend private university. So the unit is actually in dollars. So from the question, we have several information, okay? Number one, we start by defining the value of the random variable, right? Which is the annual cost to attend, okay? Private universities, right? So this is basically our x or our random variable. Okay, so we know that x is normally distributed. So we learned that the normal distribution is characterized by two things. One is by the mean, and the other one is by the, the standard deviation. So x is normally distributed with mean 26889 and the standard deviation of 4,500. Okay, so they're asking you 95% of all students pay less than what amount? Okay, so in other words, we want to know how much is this x. Okay, so now to find x, we can actually use the standardizing formula. Okay, remember the standardizing formula, z equals to x minus mu over sigma. Okay, so from the question, we know these two values. So we basically can replace sigma and mu. Okay, so let's write it down. Z equals to x minus 26889 over 4500. Okay, so now we notice that there are two unknowns here. We don't know x, which is what we're going to find, and we don't know z either. But the thing is, we can find out what z is by sketching the areas in question. Okay, so how do we do that? Here, let's sketch. Basically, what are we sketching? We're sketching the problem. Example 16, okay? So here's our normal distribution. Now the center is the mean, which is 26889. Okay, so now the question says 95% of the students pay less than what? Okay, so the key word here is less. So how do we want to shade less? Do we shade it this way to the right, or do we shade it to the left? Okay, so less, obviously it's this way, right? Okay, now 95% is more than half. So we know that this one is half or 50%. So obviously 95% has to stretch or go beyond it, right? So let's say it's somewhere here. Again, it's up to you where you want to stop. You can put it here or here. It's because you're the one drawing it. So let's say all of this is 95%. Okay, so from here up to this point is 95%. So this 95% is divided into two areas, right? 50% here, the first half, and here is 45%. 50 plus 45 is 95%. Okay, so we already learned this is x, right? So we want to know what is this x here. But we also know that we want to use this formula standardizing formula. So I told you in class before the MCO that imagine there's a parallel line here, which is the Z value. Now, whenever we standardize the mean, it becomes 0, right? So now, whenever we standardize this X value, we will get Z. Now, how to get the Z is very simple. We can actually find it from the normal table. Okay, now go and open your normal table. Okay, I don't have it with me at the moment. I need to run back to the office. But if you have your normal table with you, please open the normal table and look at the body, you know, not the one outside, the body, the inside of the normal table. Try to find the Z value that is closest to 0.45. Why 0.45? Because here, we're looking at this area here. Okay, it's basically 45%, right? So we want to know the value of Z that corresponds to this 45%. So you look at the closest Z value, closest to 0.45, you'll find that there will be two values. One is 1.64 and the other one 1.65. Now, because they're of both same distance, we choose the bigger one. Okay, so basically the Z value here is 1.65. And since it's to the right of the mean, it's positive. Okay, so now let's go back to this formula and we can write down the Z now. Okay, so because we want to find X, right? That's the unknown. I'm going to leave the X on the left-hand side. X minus 26889 over 4500 equals to 1.65. Okay, so X minus 26889 is, okay, this one, you bring it to the right, so we multiply 1.65 multiply with 4,500. Okay, so this is 7425. Now we want to find X, so 7425, this is minus, so bring it to the other side, becomes plus. So 7425 plus 26889, we will get 34,314. So does this make sense? Okay, let's check it out. 34314 is obviously more than the average, so yeah, it does make sense. 34314, it's here, this X. So in other words, I hope you can try to rationalize what we're doing here and go back and try to understand the question. So in other words, let's summarize. 95% of the students pay less than 34,314. Okay, now let's look at the next example, example 17. The U.S. Environmental Protection Agency, EPA, publishes figures on solid waste generation in the United States. 1 year, the average number of wastes generated per person per day was 3.58 pounds. Suppose the daily amount of waste generated per person is normally distributed with a standard deviation of 1.04 pounds. Of the daily amounts of waste generated per person, 67.72% would be greater than what amount? Okay, so just like before, we begin by defining the random variable. Here, X is the amount, okay, or the amount of wastes generated, okay. I'm sure all of you have better handwritings than me, so do ignore that. And X is normally distributed with mean, what's the mean? Okay, 3.58 and standard deviation of 1.04. Okay, so they tell you how much do people throw. Okay, what are the amount of waste generated by 67.74% would be greater than what amount? Okay, so let's sketch the area. Again, the average here is 3.58. So now we want to sketch 67.72% greater than. Now the example before was less than, so we're shading to the left. Now greater than. Okay, so we're going to shade it to the right. Okay, so this is half. So obviously 67.72 is more than half, right? So it would be somewhere here, right? So this is from here to here, this is 67.72%. Now this part is 50%. The remaining balance is 17.72%. So just like before, try to find, okay, sorry, here's the X that we want to find. Okay, here's X, here's Z. The corresponding mean, which is standardized as 0, the corresponding value of X is minus Z. Why minus? Because we are to the left of 0 this time, okay? So why don't you pause the video and try to figure out what is Z first by the same way we did in the previous example. Okay, so if you look at the normal distribution table, okay, try to look in the body, okay, the center part of the Z table. Try to find what is the closest value of Z, okay, which is closest to 0.1772. Okay, 0.1772 is 17.70%. You will find that the value is 0.46. Okay, so what it means is we can write down here the Z is negative 0.46. Don't forget to write the negative, okay, because we are to the left of 0. Now, just like before, we can use the standardizing formula to find x. Okay, so the standardizing formula is Z equals to x minus mu over sigma. So we know Z is negative or minus 0.46 equals to x minus 3.58. Remember, mu is 3.58 over 1.04. So by using simple algebra, you can put x, which is the unknown, on the left-hand side. So we can get 3.58 plus minus 0.46 times 1.04. Okay, so basically by solving this, you will be able to get 3.10. Okay, so this is your answer. Okay, the 67.72% of the people would be throwing more than 3.10 pounds of waste. Okay, so we've come to the last part of today's lecture, which is the normal approximation to binomial probabilities. Now, if you remember, we've already learned binomial distribution. What is a binomial distribution? A binomial distribution is a discrete type of probability distribution. Here, I've written down the conditions. What does binomial probabilities entail? Remember the 4 criteria. Number 1, it consists of n fixed number of trials. Number 2, there are 2 possible outcomes. Remember from the word bi here, 2 outcomes. So we're focusing on the number of success, which is x, okay? And the 3rd criteria is that the probability of success remains the same from one trial to another. And finally, each trial is independent of any other trials. Okay, so now we can use, of course, when we want to solve binomial probability questions, we use the binomial table, okay, for small values of n. However, it follows that if we have large values of n, it would actually be worthwhile and saves a lot of time that instead of using the binomial method to solve the problem, we can actually find the answer by applying the normal distribution. Okay, so basically this is what it means. Okay, in other words, let me try to keep it simple. The question is a binomial distribution question, but we can use the normal distribution to approximately find the answers to that question. Okay, but of course there are several conditions. There are 2 conditions, in fact. Condition number 1 is when we multiply n times pi, in other words, this is the mu, right? N times pi and n times 1 minus pi must both be greater than 5. Okay, so if these 2 conditions are met, then only we can use this normal approximation to binomial probabilities. Okay, so if you turn to this particular slide that I've given you, okay, approximate a binomial distribution, notice that the larger the number of sample size, the closer or it approaches normality. Okay, so this is basically the main reason why we can use the normal distribution to solve problems for binomial distribution. Okay, so the condition is it has to be a large sample size. Okay, so here, so I would like to explain that when we want to adopt the normal approximation to binomial distribution, we do need to make a little bit of tweaking. Okay, so that is called the continuity correction factor, CCF. What this CCF entails is that we need to either plus or minus 0.5 on the x value, depending on the question. Okay, why? Okay, the main reason is this. Okay, so if you noticed, okay, so the black bars, okay, those are the binomial distribution, right? They're bars because they are discrete distribution. However, the one encompassing the binomial distribution is the normal distribution, which is the green line. So if you notice that although they look very similar, we have several parts which are, it's incomplete, right? You look at this part. The thing is, if I press it, okay, if you notice that there are some empty slots there on the side there, this is what it means by we need to make the adjustment, plus half or minus half. All right, so let's look at how to apply this continuity correction factor, or CCF, in more detail. Okay, so depending on the circumstance of the question, you either plus half or minus half. Let's look at the first case. If you're asked to find the probability that at least x occurs, we need to minus half. Okay, so let's write down here. Okay, sorry. Okay, let's try to explain how the CCF works. Okay, let's look at the first case. If you're asked to find the probability of at least x occurring, let's see here. Let's say you want to find the probability that x is at least 5. So what you need to do, according to the rule here, is you need to minus half from the x. So what it means is, okay, so how do we write it? How do we standardize? Remember, whenever we standardize, we straight away convert x to z. Okay, here basically we don't write it as 5 anymore, but it becomes 4.5. Okay, I repeat, why is it 4.5? Because according to the rule here, whenever you want to find the probability of at least x occurring, we need to deduct half from x. Okay, so that is why it becomes 4.5 minus mu over sigma. Okay, so this one depends on the question. Okay, so this is case number 1. Now, case number 2, it states that for the probability that more than x, more than 5, okay, just now was at least 5. Now, more than 5, what we need to do is we need to plus half. Okay, so it becomes 5.5. Okay, it's not 5, it's 5.5 minus mu over sigma. That's case number 2. Case number 3, if you want to find the probability that x or fewer, in other words, it's at most, right? At most 5. So what we need to do is we need to add half to 5. So it becomes 5.5 minus mu over sigma. And finally, case number 4 is if you want to find the probability that fewer than x, fewer than 5. So what we need to do is we need to deduct half from 5. Half deducted from 5, it becomes 4.5 minus sigma over, minus mu over sigma. Okay, so some students ask me, how can I remember this, madam? Okay, the thing is, some students prefer to memorize. Personally, I wouldn't advise you to memorize because, if you're panicky during exam, you may just memorize it wrongly. So that would be, it'll just put you in trouble. So try to understand this. Okay, now let's look at this part. What does it mean by at least 5? Okay, here if you have a number line, okay, right, so here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Okay, so if you want it to be at least 5, does it include 5? Yes. So you want it to be at least 5 means 5 or more, right? So you want 5, 6, 7, 8, 9. In other words, you want here onwards. So this is at least 5. Okay, so at least 5. So when you want to say at least 5, you want to include the 5. So just to be sure, because originally the question is binomial. Okay, so the data are discrete in nature. So if you want to really make sure that 5 is included, so to be safe, why don't we just go a tad or a notch at the back? Okay, so 4.5 is here, 4.5. So if we were to take it 4.5, so definitely we will include 5, correct? So in a way, we are being prudent. Okay, so in the second case here, when you want to find the probability that x is more than 5, meaning you don't want 5, you want 6, 7, 8, 9 onwards, right? So you want it to be 6 onwards. So if you don't want to take 5, so in order to be really absolutely certain that we don't take 5, why do we take it a notch higher? So that's where we take 5.5. Okay, so why don't you try to rationalize these two? Okay, let's look at example 20. IIUM has announced that it will admit 2046 students for its upcoming September intake. However, the university has also announced that it only has Mahala room spots for 1655 first-year students. If there is an 80% chance that an admitted student will decide to accept the offer and attend IIUM, what is the probability that IIUM will not have enough Mahala room spots for the first-year students? Now, when you read example 20, do you know that it's a binomial distribution question? Well, actually it is. Okay, remember what is a binomial distribution? There are four distinct characteristics, right? One is there are two outcomes. Okay, and then we have x, which is the number of success. Then we have the pi, which is the probability of success, which is the same. And we have independence, independent trials, independent outcomes from one trial to another. Okay, so basically example 20 is an example of a binomial distribution question. Okay, so x is the number of students. Right, so we have x here, and n is here. So n is basically 2046. Okay, pi is given as 0.8. Okay, so please refer to your notes so that you can see example 20. So we get all of this information from example 20. Now remember, to apply the normal approximation to binomial, we have to make sure that it fulfills several conditions. Number one is we have to have a large sample size, and then we have to make sure that n pi is greater than 5, and n times 1 minus pi is also greater than 5. So you can actually check it out. N times pi, obviously this is more than 5. 2046 times 0.8, you get 1636.8, so it's more than 5. So likewise, this is also more than 5. So both of these conditions are met. Check. Therefore, we can use the normal approximation to the binomial. Okay, so be sure to justify. You need to be able to justify that we can use this. How to justify? Show this. Okay. Right, so let's go on and try to answer the question. The question is, what is the probability that IIUM will not have enough Mahala room spots for the first-year students? Okay, so how do we write that? Not have enough. So it should be more than 1655. Because in the question they mentioned that Mahala only has spots for 1655 students. So if it's more than that, therefore we don't have enough rooms lah, right? Okay, so since we know that we can solve this question using the normal distribution, we have to apply the CCF, continuity correction factor. Remember, this is more than x. So what we do, we have to plus half to this. So it becomes z. Why z? Because we're standardizing. So x becomes z. Okay, greater than 1655.5, because we have to add half to x. Okay, minus the mu. Okay, oh, I didn't show you how to find the mu yet. Minus mu over standard deviation. Okay, so why do we find the mu first? Mu is basically n times pi. In this case, you just multiply them together. So we will get, okay, I've done the calculation on the side, n times pi, which is 2046 times 0.8. So it becomes 1636.8. Okay, now standard deviation, sigma, is basically n pi times 1 minus pi. Okay, square root it. So here is, so it's basically this now, 2046 times 0.8 times 0.2. Okay, 0.2 is 1 minus pi square root. So anyway, you will get 118.093. Okay, so these two values are very important. What do? We put it in the calculation. All right, so here we can say z is greater than 1655.5 minus, what's your mu just now? 1636.8. Okay, not enough space here. Over 18.093. Okay, so you get z is greater than 1.03. Remember, leave your z to 2 decimal spaces, all right? So from here, okay, how do we do this? Oh God, I'm running out of, oh, okay, so I've got on the page. So here, remember just now we wanted P greater than 1655. So anyway, our average just now was, what was our average just now? Our mu was 1636.8. So more than that, it would be to the side, right? 1655. So we want this area. Okay, so what does this mean? What this means is, this is half, right? Half should be minus this probability. Okay, so now let's go back here, right? So go and look from the table, Z table, look at what is the probability of 1.03. Okay, the probability of 1.03 is 0.3485. So check that out. Okay, go and look at the Z table, look at 1.03, you will find the value 0.3485. So what you need to do is 0.5 minus 0.3485. Why minus? Because as I showed you just now, we want this area. So half minus this area. So 0.3485 is actually here, from here to here. Okay, if you paid attention to the class before MCO, how to read the table is always from the center. Okay, from the center to this particular value. Remember, 1655 here is actually 1.03. Okay, this is X. Down here is our Z. Okay, we standardize the mean, we get 0. We standardize this, we get 1.03. So from the mean to that particular value is the probability. So we don't want this area, we want this area. That is why it's half minus what we had. Okay, so let's go back here. So basically your answer is 0.1515. Please attempt examples 19 by yourself.